Hi guys, so now we are going to do a problem based on the concepts that we have recently learned. So the problem statement goes like this. You have been given an integer array of size n, okay? And apart from this integer array, you have been given three integers which are, let's say, p, q and r, okay? Now what you have to do is you have to consider an expression like p multiplied by array of I plus q multiplied by array of j plus r multiplied by array of k. Of course, this I, j and k are some indices of the input array, okay? And now what you have to do is you have to basically maximize this expression. So maximize this expression p into array I plus q into array j plus r into array k, where array I, array j, array k are the three elements chosen from the input array. The only constraint is that I must be strictly smaller than j. I have written strictly smaller, not even equal, okay? And j must also be strictly smaller than k, right? So look at this expression, pause the video for a while and then try to understand the question completely, okay? So as you might have understood, let's say if your input array is like this, then you're supposed to select any three elements from the array. But when you choose those three elements from the array, the important thing is this. So let's say if this is your first element, by first element I mean the element to be multiplied with p, then your second element cannot come from before this. It must come after this because j has to be greater than I, right? Okay, so let's say this is your first element and this is your second element. Then because of this constraint again, your third element must lie towards the right side of second element because k has to be strictly greater than j. So this must be your third element. So this is the constraint that is to be kept in mind while choosing any three elements from the array and then evaluating this expression. So the basic idea is choose the three elements in such a way that the value of this expression is maximized, okay? So just pause the video for a while, think of the brute force, which is the most naive solution, and then think if you can see some hints for optimization based on what we have learned, okay? So pause the video for a while and then think. Okay, so let's take a very simple example. Let's say my array contains these elements 1, 2, 3, 4 and 5, and let's say the values of p, q and r are 1, 2 and 3. Feel free to pause the video and again just come up with the output for this input. So let's say this is your array and these are your p, q, r. What do you feel would your output be? Okay, so just take a pause and think. So in this case, if I pick this thing as my first element, this as second and this as third, then I believe I will get the highest possible value, because let's perform that multiplication. 1 into 3 plus 2 into 4 plus 3 into 5, and this comes out to be 26. So I have ensured that this thing is being obeyed, okay? And if you choose any other triplet apart from these three obeying this particular thing, then you would see that whatever result you get, that would be smaller than or equals to this 26. So for this particular input, my output is 26. So what are the brute force approaches that we might have thought so far? So I think the easiest thing that I can think is that it's regarding triplets, right? So let's consider all the triplets. Now the easiest way to consider all the triplets is by simply running three nested for loops, okay? So what you can do is that you can run your for loop where you can say that your I goes from 0 to n minus 1, and here from here you are going to get array I, which is going to be your first element, okay? Now if ith index has been chosen to represent the first element, the second element must come after ith index. So the nested inner loop that comes inside will have j, which will run from I plus 1, right? So it will run from I plus 1 all the way till n minus 1. Again, when you come inside, so you have selected your I, and because of this condition you have selected your j, which is coming to the right side of I, and now you have to select your k, which must come even right side of the j. So now you will run your inner loop where your k will go from j plus 1 to n minus 1. And now when you are inside here, then what happens? Then basically you have chosen an array I, you have chosen an array j, you have chosen an array k. Your first element, your second element, your third element, right? And they are obeying this particular rule, okay, because of the style in which the loops are written, their initiations are written, right? Now all that you have to do is you have to create this expression and keep on updating an answer variable which can represent your overall answer. So what you can do is that you can initialize your answer to something because you want to maximize it, so you want to minimize it, so you want to basically initialize it to as low value as possible. So it could be like int underscore min, which is minus infinity, and every time what you're going to do is you are going to say that your answer will be updated in this manner. So answer equals to max of answer, comma, whatever is your current value would be p multiplied by array of I plus q multiplied by array of j plus r multiplied by array of k. So this is what you can keep on doing, and then you can eventually return your answer. This is the most trivial approach which all of us can think. What is the time complexity for this? So you can say that outer loop at max it is going to run for n times, and same thing for this and same thing for this. So approximately it will run for order n cube times. It will not exactly have n cube iterations, but approximate number of iterations will be n cube, which is a lot. So if n is something like 10 raised to power 5, you are going to get time limit exceeded, right? So how to do better? Think about that. So if you have not thought of any approach that is slightly more optimal than this, you can prefer to pause the video again. Yeah, so guys, looking at this example, some of you might be wondering that, hey, how about choosing the 3 maximum elements and then multiplying them with p, q and r? So this might be a thought that would have come, but it has a counter example. Let's take that. So let's say you have something like 1, 2, 3, 4 and minus 5, okay? And then let's say you have p, q and r is minus 3 this time. Now in this case, the logic of selecting the 3 maximums and multiplying them with p, q and r is not going to help, because if you do that, the 3 maximums here are this, this and this. Now if you multiply 2 with 1 and you multiply 3 with 2 and you multiply 4 with minus 3, you will get 2 plus 6 minus 12, which would be minus 4, right? But there is a better choice that you might have taken. So let's say if you would have selected 3, 4 and minus 5, okay, and this is obeying the constraint, right? I smaller than j smaller than k, and now you multiply this with this, this with this and this with this. So 3 into 1 will give you 3, 4 into 2 will give you 8, and minus 5 minus 3 will give you 15, and this gives you 26, okay, which is better than this. So the logic of picking the 3 maximum elements is always not going to help. Why? Because the array can contain negative elements also, and PQR can also be negatives, right? So this was one case. There can be multiple different cases, like Q and R can be negative, P can be positive, or all of them can be negative. So if you try and handle all the different cases, you might not be able to write a perfectly working code. Chances are very, very high that you might miss out on some edge case or something like that, right? So a better idea is to think of something which takes care of negative things also, and is optimal, and as well as it is easy to code. Okay, so let's think about that. For that, I'll suggest you one thing. Let's take a step back from this problem and let's simplify it to a very, very simple kind of question. So let's think that we had an array. Okay, so you just have this array containing n elements, and all that you have to do is you have to maximize this expression, which is array I plus array j plus array k. There is no p, q and r over here. Even if they are there, then they are all equal to 1, right? I believe you get that, right? Because p, q and r were variables over here which were being sent to you as an input, right? And here there are no p, q and r, and even if you see them as 1, 1, 1 each, right? So here all that you have to do is you have to maximize this, but this condition still holds. So you have to maximize this thing under this constraint. Pause the video for a while again and then think about it. So as some of you might have thought, the brute force approach of order n cube is still applicable here, okay? But can I say something that, hey, here all that I can do is that I can maybe pick up the 3 maximum elements from the array and that's it. That's how my job is done, right? In fact, yes. Why? Because if let's say I have an array and let's say you pick 3 maximum elements of the array. Let's say the 3 maximum elements of the array are 100, which is present here, and let's say then you have 70, and then let's say you have 90. Let's say these are the 3 maximum elements. So it might so happen that the first maximum is here, okay, and third maximum is here, and second maximum is here, okay, or their order is jumbled up. But picking 3 maximums will always give me the highest possible sum, right? Because if instead of 70 you prefer to choose anything else, then that has to be smaller than 70, because you are saying that 100, 90 and 70 are the 3 maximum elements that you have, right? So here, because p, q and r, even if they are there, they are just like 1. So picking any negative element and multiplying them to -1 is not going to be useful, because you will not have anything like -1. Your p, q and r all are simply positive, right? So in such a case I can say that, hey, just find out the 3 maximum elements of the array and then add them up, and then that would be your answer, okay? So this is the way in which you can very easily solve this. Now the question is that, can I try to solve it in a bit different manner? Maybe in a manner which is based on the concept that we have learned, prefix sum and suffix sum, okay? So before explaining it, I would want you to pause the video for a while again and then think if something like that could be introduced over here. Okay, so let us all understand it. Let's say I'm trying to solve the question for this array under these constraints. As I already said, there are 3 elements, first, second and third, okay? Now there are different combinations of first, second and third elements, almost order n cube combinations. So if I try them out, I'll have to write 3 nested for loops. I can say that let me take an approach where I'm trying to fix my middle element, which is my second element. Let's say you try to fix your second element. Let's say you say that, hey, I don't worry about my first and third, I just worry about my second element, and I'll pick my second element as, let's say, 15, whatsoever it is, okay? If you pick your second element as 15 for sure, then in order to maximize this expression, you have to pick first element from this much part and third element from this much part. Think, which kind of element would you love to pick from this part, and which kind of element would you love to pick from this part? Pause the video for a while and think. As you might have guessed, you would have wanted to, pick the maximum element from here and maximum element from here, because you have just fixed your second element. Now you have got choices for your first element. So let's say you had a 1, you had a 5, you had a 90, okay, and you had a 7, you had a 77, and then 0. So if this element has been fixed by you, okay, then in order to maximize this expression, you would want to pick the maximum element from here to here, which is 90, and maximum element from here to here, which is 77, and now 90 plus 77 plus 15 would be the maximum possible sum which is obtainable if you fix your middle element. So guys, this gives us a great idea. The idea is that if, let's say, I try to generalize it and say that, hey, my middle element is some jth element at jth index, then all I need to know is that what is the maximum value from 0 till j minus 1. So you are interested in knowing maximum from 0 till j minus 1. And for the choice of third element, you are interested to know the maximum thing from j plus 1 to n minus 1. And we have already discussed this. So the maximum from 0 to j minus 1, this is like a prefix max ending at j minus 1. And this is like suffix max starting at j plus 1. So this is an important point to understand. So all that you have to do is you have to one by one fix your middle element, and for any middle element that you have fixed, you have to find the best possible first element, which is nothing but prefix max ending at j minus 1, and best possible third element, which is again nothing but suffix max starting at j plus 1, right? So this is the route that we can take, and then we can very easily solve the problem, right? This particular problem. So just think how would the code of this look like if I try to use this approach. So all that I would do is that I would have a prefix max array of size n, and then I would have a suffix max array which will again be of size n, and I know how to populate my prefix max array by traversing from this end, and I know how to populate my suffix max array by traversing from this end. Of course, you have to initialize your prefix max of 0, which will be this element itself, and suffix max of n minus 1, which will be array of n minus 1. And then you basically initialize all the values over here. This will take you order n time, this will take you order n time. So basically, their initializations would just take you order n time. And then, one by one, in the original array, you can just keep fixing your middle element. And then once you have fixed your middle element as array of j, you know that the best possible first element will be p max of j minus 1, because that is the prefix max from 0 to j minus 1. And the best possible third element will be s max of j plus 1, because that is the maximum possible thing from j plus 1 to n minus 1. Okay? So now just think, because this constraint is applicable, so if you are supposed to kind of choose your middle element, what are the choices for middle element that you can have? Can you ever choose this as your middle element? No, because if you choose this as your middle element, there will not be any first element. And for the same reason, this can never be your middle element, because if this is your middle element, then you will never have your third element, right? So here you end up missing your first element, and here you end up missing your last element. So a middle element can only be something from index 1 to index n minus 2, which is the second last index. So what you will do is you will simply iterate from index 1 to n minus 2. And now if you are in a particular ith iteration, that means that your current middle element is array I. So what you want to know is that what is the best possible first thing that you can get. The best possible first thing that you can get is prefix max that ends at I minus 1. The middle thing is a of I, and the third thing will be suffix max that starts at I plus 1. And then you can store this value in some variable called x, and then keep on updating your answer. So if, let's say, you have initialized your answer to int underscore min, you can always update like this: answer equals to max of answer comma this x, and then eventually you can return this answer. Spend some time looking at this code. This is simple enough. You can pause the video for a while and then take a look. And now all of us can see that even this logic is order n, because there are just order n iterations. So I can say that order n pre-processing time here and order n is the core logic that I ran here. So overall I solved this problem in order n time. Of course I needed order n extra space for prefix max array and similar extra space for suffix max array. Okay, now let's think one thing. If I can solve this problem in this manner, I can solve the original problem as well, right? So let's try to map, okay? So let's say this was my array. If you have fixed your choice of second element, let's say this is your second element, okay, which is array of j, okay, then the value that you will get corresponding to this will be equal to q into array of j. Now you want the best possible first thing, which is this, and the best possible third thing, which is this. So all that you have to do is, you have to find the maximum value of p into array I, where array I must be chosen from 0 to j minus 1, right? Similarly, you have to find out the best possible r into array k, where array k must be chosen from j plus 1 to n minus 1. And it looks like this is easy. This is also just like, finding prefix max and suffix max. The only difference is that here there is a coefficient that has to be multiplied. Okay, so I can say that, hey, here I'll just slightly change the definition of my prefix max and suffix max. So here I'll say that my prefix max ending at I, let's say this is my array and this is my index I. Now my prefix max ending at index I will tell me that what is the maximum value of this expression, where I is something in between 0 till here, right? That is how it is being defined. My prefix max I is being defined. So I can say that, hey, my prefix max 0, because there is 0 means that you are considering elements from 0 to 0, there is just one element. So the maximum value of this expression, if you consider from 0 to 0, will be nothing but p multiplied by array of 0. And then you can populate prefix max ending at 1, ending at 2, ending at 3, and then so on and on and on. For that you just have to simply run a for loop where you run from I equals to 1 to n minus 1. And all that you have to do is, you will say that, hey, prefix max ending at index I will be equal to, how many choices do you have? So if you know prefix max till here, you can very easily know prefix max till here, which is I plus 1. So there are just two options. Either it will be p multiplied by this thing, or it will be whatever is the prefix max ending at I. So you can say that prefix max ending at I, this thing can be written as max of whatsoever was the prefix max ending at I minus 1. This is the first choice, and second choice is p multiplied by array of I itself. So this is the way in which you can initialize your prefix max array in a very easy manner. Similarly, you can initialize your suffix max array also. When you are initializing your suffix max array, then the same kind of route will be chosen by you. The only difference will be that you will do it from index n minus 1 to index 0, and you will initialize your suffix max n minus 1 first, which will be equal to, here the coefficient is r, so it will be r multiplied by array of n minus 1. Okay, and then you will travel back. So you will travel from n minus 2 to index 0, and now you will write that suffix max that starts at, let's say, index I, it is equals to max of the two things. So if you need to know that what is the maximum value of this expression, if you are considering the portion from here to here, then there are just two choices. Either it will be whatever was the maximum from here till here, which is, let's say, if this is I, which is from I plus 1 to n minus 1, or it will be this element multiplied by r, the same logic that was applied over here. So this thing will be equal to the max of suffix max that starts at I plus 1, or it will be equal to r multiplied by whatever this particular element is, which is nothing but array of I. This way you have initialized your prefix max, suffix max, where there is a coefficient, right? R over here, P over here. Okay? And now the same logic will appear over here, where you will choose your middle element from index 1 to index n minus 2, and then whenever you have chosen, let's say I to be your middle element, then the contribution that you will get will be q into array of I, and then you would be interested in knowing the value of p max from 0 to I minus 1 and the value of s max from I plus 1 to n minus 1, right? So that would again be a very similar logic where all that you would do would be you consider the portion from 1 to n minus 2, and all that you have to do is, so first you initialize your answer to int underscore min, and then you say that hey, your answer is being updated as max of answer comma whatever is the current choice. So what have you done? You have chosen ith element to be your middle element, so corresponding to that you get q into array of I, and then the best possible choice for your first element would simply be equal to p max that ends at I minus 1, and the best possible choice that you have for third element will simply be equal to s max that starts at I plus 1. This is how your answer keeps on getting updated, and eventually you return this answer and your job is done. As you can see, order n time to populate p max, order n time to populate s max, and then order n time over here. This is how you can very easily solve this question. So this is nothing, this is just pure pre-computation thing that we have done over here, and we have seen that it can be extended even if there are certain coefficients that are involved. So as long as you are computing something from one end of the array, you can always perform pre-computation and compute it in a very, very easy manner. Okay, so that was the important thing over here to understand. Now, apart from that, certain times what can happen is that the constraint that has been given to you might look a bit different. Now this is very important for you to understand. So if, let's say, there is a question which says that the constraint is maybe like this, then think, what does it mean? Pause the video for a while and then think. So it means that the three elements that you are choosing need not be distinct from each other. Okay, so it basically means that you can choose array of 4 as first element, array of 4 as the second element also, and maybe let's say array of 11 as third element, because 4 is smaller than equals to 4, this is smaller than equals to 11, right? So this can also be handled in a very easy manner. Now when this thing is being talked about, then your first element can also play the role of middle element, which is I equals to 0, right? Because you can choose I equals to 0 as middle element also, and you can choose the same thing as first element also. Similarly, you can choose this thing as the middle element also and as the last element also. Okay, in generic terms, you can say that if you have chosen this index j as your middle element, then this is the amount that you get. Now you would be interested in the p max, not from here till here, but from here till here, which includes this, right? Because what if p into array I was maximum for I equals to j? So you would need to know p max ending at index I. Similarly, you would need to know s max which starts at index I, because again it can happen that the maximum value of this expression is getting obtained when my k is equals to j, right? So these are the important things to be kept in mind. So just a small change that you would have to do is that while running this thing, you'll have to start from I equals to 0, and when you choose array of I as your middle element, then you would need to know p max ending at I, not at I minus 1. Okay, and similarly you would need to know s max starting at I and not I plus 1. These are the small changes. So let us summarize it. So you were basically given a question in which you saw that there were different combinations, so you were tempted to write 3 nested for loops. Now if you try to map that problem to a simpler problem, then you see that maybe picking the 3 largest elements get the job done for you. Now there is another line of thought where you pick your middle element and then you figure out that, hey, what is the best possible first and what is the best possible last. That gives you a hint of prefix max and suffix max, which got extended to the case where there are, coefficients also involved. And once you figured it out, then the things were very easy. And then to finish it up, if this thing is different, then your logic just changes a bit. Pre-processing part remains the same, just logic changes a bit, the core logic that you have. Okay. Let's have a food for thought over here. So here you are having two arrays, prefix max as well as suffix max. This question can be solved using a single array also. Let's say you just have prefix max, and suffix max is something that maybe you don't need an array for that. So maybe you can do it just by using a single variable. Okay, so think over it, think for some time, and then you should be able to get that. And if you don't get that, then you can ask the doubts on the discussion forum. Okay, cool.